So, exception handling in C++. See, sometimes when we write program, some unexpected error can occur in the program. Okay, some unexpected errors can come, right. So, in when you write, for example, you wrote a program int c equal to a by b, and when you are executing the program using scanf or using cin, okay, using cin statement, you are reading the values as a and b. So, when you write this, if the user gives a as 10 and b as 0, generally c equal to a by b. So, when I am dividing 10 by 0, we know this is not possible because it is infinite. Okay, this is infinity value, but it is actually undefined. It means undefined. You cannot divide a number 10 by 0. So, we do not know how to know, the program does not know how to respond to this, because it cannot calculate this value. You give other values, the same program will work for other numbers other than b not equal to 0. But if you give b as 0, some unexpected error can come there, right. Or sometimes your program is perfect, but some system issue or some resource issue is there, right. So, which we do not know because of RAM failure or any other failure which can interrupt the program to stop its execution, right. So, expect some unexpected problem can arise when you are executing the program, right. It is maybe because of the user entry or user involvement, or without the user involvement, some error can come in the program, right. Some execution errors when you are executing the program, some no issues can appear in the program, right. Such errors or the unexpected problems in a program, right, are called as exception. Okay. If you see the definition, an exception is an unexpected problem that arises during execution of a program. Our program terminates suddenly with some errors and issues. Okay. Another way of understanding exception or another example is that, suppose you declared an array int a of 5, okay, and you have assigned values to this 10, 20, so on, 5 values. Now, when you are printing, you gave like this, I less than or equal to 5 I plus plus. Since you copied this line from some other program, you are writing something like this. So, it is a of I equal to maybe I am filling these values. So, but we know array indexing begins from 0 to n minus 1, that is, since it is 5, it is from 0 to 4. But here what you are doing, you are starting the loop from 1. So, what it is doing, it is putting a of 1 equal to 1. Again, not this, if I have given some zeros here like this, if I had filled with zeros, okay, then it makes sense. So, a of 1 equal to 1, a of 2 equal to 2, this is valid because I have index from 0 to 4. But the last case, in the last for loop, what will happen here, a of 5 is equal to 5. Do we have a of 5 here? No, array indexing is strictly from 0 to 4. So, you are trying to access an index which is out of the range of the given array size, right. So, these kind of errors which happen either because of manual or human intervention, human mistakes, or because of system failure. There can be many reasons why the system is failing. Your program may crash sometimes, your compiler may not execute properly, or the resources required for executing a program might not support for at that moment, right. So, these kind of things are called as exceptions. Okay. So, you have to handle that exception. In C programming, we do not have this feature of exception handling. Okay, we do not have exception handling there, right. C++, in C++ it is inbuilt, meaning any program in C++, we can handle exception in C++ programs, because we have that feature, like we are having class object, we are also having this implementation of this exception in our program, right. So, an exception is an unexpected problem that arises during the execution of a program. Our program terminates suddenly because of some errors, right. So, it occurs during running of a program, during runtime only this kind of problems can come. So, the process of handling these kind of exceptions is called exception handling, right. So, what happens when using the exception handling mechanism, the control from one part of the program where the exception is occurred can be transferred to other part of the code. So, you have to take some action, you wrote a program, some exception is has occurred there, then you should handle that exception. You should handle that exception means your program should not give any error message, you should terminate it properly. We will see an example to understand this exception handling, then we will go and see the details of how this exception handling works and what are the syntaxes of handling the exceptions in C++. I will just quickly go to an example problem, right, or maybe another one here. This is right. See this example, divide by 0 error problem. I will explain you about this keywords here. I am reading a number numerator, I am reading another number denominator, and I am writing if denominator is 0, division by 0 not allowed. Okay. So, and otherwise if this is not the case, otherwise result equal to numerator by denominator. If it is only 0, you are stopping the program, right. If it is not 0, the control will be shifted to this line, and from this it will give the result after division RES equal to numerator by denominator. Okay. So, we are trying to catch that error. Okay. So, whichever block of code, whichever lines of code we are expecting some exceptions, or your main logic, the total program, you should put it in one block, that is called try. Okay. In a try block, you have to include that whole code, your logic. Maybe this is sorting logic, this is sorting array elements, this is that logic, but that main logic you put it under try block. Okay. So, this will done. If some error happens here while executing this block of code, while sorting the given array elements, if some error comes, maybe index error or 0 error, like that, we have so many exceptions are there. If those exceptions occur while you are executing this program, that part you will capture. Okay. We can capture the error. Okay. Using the exception handling mechanism, we can capture what was the error and print it on the screen. We can print it on the screen. So, the user, when he executes the program, he will understand why this error has occurred in the program. Okay, right. So, the reason can be anything, any exception can happen, but why the program failed, sometimes we cannot decode, sometimes we do not understand why the program is not giving proper output. Okay. Right. So, those kind of errors can be captured and can be shown to the user as the output. This program worked fine till here and some exception occurred, that is, this is the reason for that exception. Those things can be given to the user. Now, it is meaningful, right? Otherwise, you do not know why the error has occurred in that. When you do that, you get an idea why the program did not execute properly. Right. So, this is about exception handling. So, we are having some syntaxes and some commands, right. I will talk about this try, throw, catch. I am just giving an example why exception is needed. In a program, when you are writing it, some unexpected errors or challenges can occur in the program, because of which the program might not execute. Right. To find out what is the reason, we have to use exception handling mechanism. Okay. Now, let us go back and study how to write a program with this exception handling mechanism. See here, right. So, this is very clear, exception is nothing but the unexpected problem. The process of handling such exceptions is called exception handling, right. There are two types of exceptions in C++. One is synchronous, other is asynchronous. What is synchronous? Because of a mistake in the input data. Okay. If manually we are making mistakes while entering the values in the program, right. Because of our input, if some error happens in the program, that is synchronous exception. Okay. Because of if sometimes the exception comes because of the disk failure, keyboard interrupts, or some problem which is related to hardware of the computer, right? Those are called asynchronous. So, exception handling in C++, it has the capacity to handle both kind of errors and tell the user properly with a nice clear message that this program has failed because of this reason. Otherwise, when these kind of errors happen, you do not know why it has failed. Okay, you do not know, these are just examples, right? So, why the program is misbehaving, we do not know. For that, you can use exception in every program. Whatever you have done till now, you can write that exceptional mechanism, then you will come to know why your program was failing, what was the mistake in the program. It is not like debugging. If some error happens like dividing a number by 0, accessing array index out of the bound, okay, array index out of bound. This is one exception in, no, this also, why, what is the meaning of this array index out of bound? You have defined array of a of 6, but you are trying to print a of 7 or a of 20, something like this. Do the indexes exist in array? No. We have a of 6 means it is 0 to 5 only. You cannot use 7 or 20 in that, right? So, all these kind of exceptions can be handled. How do we handle that? How to write a program, or how do we implement the exception handling mechanism, right? It can be implemented using 3 keywords. Using 3 different keywords, we can implement this exception handling mechanism. Try, catch, throw. Okay, try, catch and throw, or try, throw, catch. Anyway, you can name it, right? So, what are these try, throw and catch exceptions? Let us try to understand what are these 3: try, throw and catch. See, before we go to the syntax, you write try, open bracket, write your actual code. Okay, write the actual program which you want to implement. Okay, then after writing the statements, here based on some conditions, you can use throw keyword, throw the exception. So, try block, inside try block you write normally you write your program, then at the end, right, you can write throw exception, and after this try block there can be another block catch. Okay, now how this works, how these 3 keywords work? See, try contains the actual code which you want to execute. If some error happens here, that will be thrown from this try block. We are throwing the exception to the catch block. So, try is throwing an exception, catch is catching it, it is receiving that exception. Okay. So, if any error happens here, that using throw keyword we are throwing the exception. So, this catch is another function type of, it is kind of a function. Okay. It will receive that exception and print, it will tell what was the error in the program. So, inside try block we will write the code which we are expecting an exception can come. Then in that try block only we will write throw keyword, which will be throwing the exception, and then in catch block we will receive the exception and it will print the message. Okay. Let us see the syntax here, right? Try, open flower brackets, code that might throw an exception. So, your logic, your program, you write it here, then throw some exception type error message. Okay. Then we have, after try block we have catch block, catch exception name, that exception object, this is exception class and this is the object. Catch block catches the exception that is thrown from the try block. Whatever error message you are sending from here, that is captured in this catch block and that prints it. It prints the message. Okay. So, we will say more detail about these blocks, right? Try, what is this try? The try keyword represents a block of code that may throw an exception placed inside the try block, right? It is followed by one or more catch blocks. If an exception occurs, try block throws that exception. Okay. What is throw? An exception in C++ that can be thrown using the throw keyword. When the program encounters a throw statement, then it immediately terminates from the current function and starts finding a matching catch block. Okay. What is catch here? Catch statement represents a block of code that is executed when a particular exception is thrown, right. So, this is about try, throw, catch. Let us see an example again and come back here. See this program, this another simple example, int main x equal to -1, see out before try. So, I will get the answer as before try first. This will come in the output screen. Then I have try block. Compiler will shift the control from here to here. Then this line. So, inside try will come in the output screen. Then I have x less than 0. What is x value in memory? X contains -1. Is -1 less than 0? Is it less than 0? Yes. Then throw x. When you are writing throw x, when you write the keyword throw and x, whenever you write the keyword throw, immediately the control from here is shifted to this block. The control from here is shifted to this block. So, catch int x. What it is throwing? It is throwing x. You see here what it is throwing? The throw keyword is throwing x. What is x value in memory? -1. So, catch int x. So, here -1 is received. When it is received -1, exception caught is the output. So, here it will come exception caught comes. This block is over now. Catch block is over, try block is over. Then at the end I have after catch. So, after catch will be executed. Okay. So, this is about a simple example, but if you observe one thing again in this example, right, we have so many things to learn here. Program will execute normally, try also normally, then statement, then condition. As soon as it encounters a throw, control is stopping here, the program control is stopping here and it is beginning here. So, the lines after throw, whatever lines we have like this will never be executed, this will never be executed. Why? Some error happened here, that is why we are shifting our control to the catch block. Then whatever is there in the catch block will be done. Later after the catch block, other programming statements will be executed. Okay. So, this is just to understand, this is not the real example, this is we define this example to manually work. See, I gave x equal to -1, I wrote this condition and I am saying throw x whenever this condition is satisfied. This is just to demonstrate how try, throw, catch works. Okay. Right. In this example also, again we have to study some terminology. I will we are yet to study them, but just see this is an example, just see how these blocks are working. Okay. Try, in that try I wrote some programming statement. If denominator is given as 0, then throw runtime error, division by 0 not allowed, whenever it encounters this runtime error, whenever it encounters this throw, immediately the control will go to the catch block. This error message is given in this E. So, exception E dot what. So, we are going to study about this runtime error. Runtime underscore error is one predefined keyword kind of a thing, and then we have exception is also a keyword and what is also a keyword. These three new terminology we will see it in coming slides, right. But this is just to demonstrate how those three blocks function: try, catch and throw. Okay. So, in try I will be writing some statements and I will write throw based on some condition. Then whatever is thrown from that here, that will be captured here and some message you can give, clear message you can specify here, right. So, the another important point is a single try can throw multiple values. A single try block can throw multiple values. Okay, it can write based on conditions. Maybe if I write some simple program, if some x is equal to 0, throw x. If x is equal to 1, throw single quote a. Like this I can have multiple throw statements in a try. Now, when there are multiple throw statements, you should have multiple catch statements, corresponding catch statements, one for integer x. So, this will come here, you can write some statement. Another catch statement for character, so char ch, right. if there is a throw here, integer value I am throwing, integer catch will receive, character I am throwing, character will receive, like this it will happen, right. So you can have multiple throw values and you can have multiple catch statements in a program. Okay. So again I will repeat what is this try throw catch. In try block I can write the actual code which I want to, which I am expecting an exception can occur. Then in that inside try block I can write one throw statement, and there should be a corresponding catch statement outside the try to hold that value and give the proper message to the user. Okay. See, multiple catch statements can be used to catch different types of exceptions thrown by the try block. Okay. So the try and catch keywords come in pairs. We use the try block to test some code, and if the code throws an exception, we will handle it in our catch block. Okay. So these two are just examples to demonstrate how the exceptional handling works using try, throw and catch keywords. Okay. So we have some properties of exceptional handling. This will help us how the exceptional handling works, or some important points about exceptional handling in C++. Let us explore some properties of exception handling. Right. See, suppose you are throwing multiple exceptions. You are throwing multiple exceptions and you want to write only one catch block. Let me take an example. I wrote try here. I am writing some statements. Then I have if x is equal to 0, throw maybe 10. I have another one else, or not else, because if I write else any one block will be executed. If some x is equal to 1, then I want to write throw single quote a. Okay. Like this, or else another case, if some other error happens, some statement, then you can write throw exception something, you can give message. Okay, you can give a message, right. When you are sending different data types, but you want to write only one catch block, you want to write only one catch block to catch all kinds of exceptions, then you have to write like this: catch 3 dots here, in round brackets 3 dots. Okay. This will this is catch all, meaning any kind of exception you throw, that this block will catch it. Generic, we can say this as a generic catch block which will work for any given throw statement. Whatever your try block is throwing, everything will be captured here. Catch 3 like this, catch 3 dots. If you write this, whether you are throwing an integer or some character or some message, you do not want to write multiple catch block. I said we can have multiple catch blocks according to the data type, according to the message. We can have multiple data types, but you want to write single catch block, simply saying that exception occurred. You want to say cout exception occurred. You want to say this. Then you can use this statement like this: catch 3 dots. Okay. So any kind of value you are throwing, whether it is 10, character or some message you are giving, right, everything will be captured here in this catch block. Okay, right. But in this example, if you see, we are having catch, character, exep and caught, and I have catch 3 dots. So I have given two things. What am I sending here? I am sending 10. Do I have a catch statement? Do I have a catch statement in the program which is receiving integer number? This is integer. This is integer. Do we have a correspondence? Right? Do we have any corresponding catch statement which will receive the integer value? No. Is it matching with this catch? This is receiving some message, text message. Okay, this is receiving some text message. So this is I am sending integer. Then automatically control will go from here to this catch block, because it can handle any kind of exception. So it will say the output default exception. So for this program, output will be default exception. Right. So this is the first property. If you want to catch all kinds of exceptions, you can use catch all block. Catch all can be written as catch 3 dots. Okay. Right. The next one, type conversions. See here, this example, I am in the try block, I am throwing a character. Okay, I wrote here catch int x. Is this matching here, data type matching here? No, this is character I am throwing, this is integer, it cannot receive that. It will definitely go to the this block, it will definitely go to the this block. The point here is to say that implicit type conversion does not happen. Okay, since I am throwing a character variable here, this catch block cannot receive that particular character here, because this is defined as integer. It is defined as integer, so I cannot receive that. So which one it will go? By default it will go to the this catch block only, because this is generic catch block. It can take any kind of exception. It can take any kind of exception. That's why we get here answer as default exceptions. Now one more important point here. Suppose you are throwing a character and you have one catch block which is receiving integer. Assume this is not there. Assume this is not there. Okay. So you wrote only try. In that you wrote throw with single quote a, and you don't have a matching. You have int x here. That's it. Something else here. So in this program, you see in try block I used the keyword throw and a character, but I have a catch. But this catch is not receiving any character value. It is receiving only integer values. There is no character catch. I don't have a function catch which is receiving character values. Then the program will abnormally end. Okay, the program will terminate abnormally, meaning some error will come to you. Some different error will come to you saying that there is no corresponding catch statement for catching a character value. The program will itself will throw error saying that your syntax is not proper. You are trying to throw a character, but there is no corresponding catch function here or catch part block in the program, right? Next one, third one. If an exception is thrown and not caught anywhere, the program terminates abnormally. That's what I am trying to say. Right? This is the example. Okay, you are trying to throw a, here, but there is catch with int x. Catch with int x. We don't have a corresponding matching catch statement here. Then the program will terminate after called after throwing an instance of char. This is the error message you get. So program has been terminated abnormally, right? Next, in C++, try catch blocks can be nested, like we are nesting if conditions, for loops, we are nesting one inside the other. We can also nest the try blocks. Okay, let's see this example to understand this point. Try, this is the first try, outer one, let's say 1. Inside that I have another try 2. For easy understanding I am writing 1 2, but you have to write try only always, because that keyword is try. Then I am writing here throw 20. So this is throw 2 only. This is throw 2 only. Now catch int n. So this is a continuous block. This is a continuous block. For this try, this is the catch. I am throwing 20. So this is receiving 20 and handle partially will come as the output. Then overall, what is this one throwing? Overall, this inner try block is again throwing 20. So for this try block, this is the catch int n. So 20 is received here, and see here we are having throw. We are having throw, right? This throw is bringing this 20 and giving it to the catch function. Okay, so I will explain with simple terms here. See, try 1, inside that I have try 2, inside that I am having throw 2 of 20. Okay, this 1 and 2 just for our encoding. Then I have catch 2 of int x. You are having some statement here, right? This is try, then you have catch, then you are having one more throw statement. Why? Every try should have one throw statement. This throw belongs to this try. I should have another throw statement. What should you throw here? What should you throw? If you don't have anything to throw, simply write throw. Simply write throw like this. Okay. So this is, when you write simply throw, it means there is another try block or another block of program above this throw, which is trying to throw some value. When you simply write throw like this, it means above this there is some block of code which is trying to throw some value. Okay. Now this will close, this try will close here. Then comes this catch int n and handle remaining. Okay. So internally throw 2 is sending 20, catch 2 is receiving it, and it will say handle partially. Then this is throw 1. The outside one is throw 1. For this try 1, this is the throw 1. You simply write throw like this. Whatever the above code is throwing, that will be carried here also. That is why this function is being executed and it will say handle remaining. So you can have one inside the other as well. So output is handle partially because this is executed first, then handle remaining, the outside catch is executed. Okay. And the last property on the important point about these exceptions is about the constructor and destructors. Okay. When an exception is thrown, all objects created inside the enclosing try block are destroyed before their control is transferred to the catch block. Meaning, see, in this class test, I have a public, I wrote a constructor and a destructor. Int main, inside try block, I created an object. T1. We know as soon as we create an object, the default constructor will be executed. So this constructor will execute. Okay. Constructor of test will come as the output. Constructor of test will come as the output when I create this object. Then I am throwing 10. So 10 is being sent to the catch block. Okay. Now before you call this catch block, you are having a close bracket here, open bracket and close bracket. Before this close bracket is executed, the destructor will execute. It will say destructor of test. Then the 10 is received here and it will say caught 10. Okay, the point here is to say that whenever you create an object in a try block, okay, before you transfer the control from this throw block to the catch block, before the control is shifted from this throw block to the catch block, right, before that this destructor will be executed. Anyhow, constructor will be executed immediately once you create an object. After that you may have so many statements, but before you shift the control using this throw to this catch block, the destructor also will be executed. That is why the answer for this program will be constructor of test, destructor of test, at the end caught I. But generally we have studied that destructor will be the last line of the program to be executed, but here it is not that. Okay. For it, within this block only both constructor and destructor will be executed, then only the control will go to the catch block. Okay. So these are few important points about exception. We can have right multiple throw and multiple catch. We will see them when we implement, when we implement some programs. No, we will try to execute this program and see there will play having throwing multiple values, receiving multiple values, receiving multiple exceptions in a single catch block, using this catch all, right. All these things we will execute and see it there. And the last point in this exception is rethrowing an exception. Okay. The next is rethrowing an exception, right. See, sometimes we have functions. So I have a function void fun. Okay. I am doing some set of statements here. Okay. So in int main, we are having a try block. Inside this try block, I am calling the function fun with some values, some x comma y, something like this. Okay. Inside try block, I am calling a function. Till now we have studied that whatever code you are writing in the try block, that will be executed, and based on some condition it will, we have a throw statement here, right. But when you are calling a function like this, here also there can be a throw statement. Here we can have a throw statement inside the function, meaning inside this try directly I am not writing throw. Inside try block I am writing a function, in that function body I am writing throw statement. That can be captured here. This can be captured here in the main. Okay. I hope you understood what we are trying to do. See, in the int main, we are having try block. inside this, after certain statements, I am calling a function fun with some values like this, and I am having a catch statement here, some error message. Okay. Then here in the function, in this function, after writing certain statements, you can throw it, you can throw the error, whatever message you want to throw. See, so directly throw is not available in the try block. It is calling a function, this function has a throw which will return back to try and which will be captured here. I hope you got it. Little indirect. Directly we are not writing in try, we are not writing this statement throw. We are not using the keyword throw, right? We are writing that in a function, right? So let us try to understand this with an example. Before we go, let us see what is this rethrowing. What is rethrowing an exception? Rethrowing an exception in C++ involves catching an exception within a try block instead of dealing with it locally, throwing it again to be caught by the outer catch block. Little confusing, I understand. Let us see this example here, right. So I have int main. We will talk about the other terminologies. Let us pay attention for understanding what is rethrow. Okay. Int main, I am calling a function outer function. So immediately compiler will come here, execute this outer function. In outer function, I am having a try block. Inside try block, I am having another function, inner function. Immediately the control is shifted here, inner function. In inner function, I am having try and I am throwing a key, an exception. I am throwing an exception. When I am throwing an exception in this try block, in the inner function, this will be executed, caught exception in the inner function, because try and catch are followed by, right, try and catch here, they are one after the other. This inner function is having a try catch, try throw catch. Okay. This catch is saying a message to me, caught exception in inner function, right. Then where did the control come from for this? It came from outer function, it came from outer function, right. So in try, inner function is there, no, that exception which is thrown here in this inner function is also returned here, that will be captured here also. Okay. The whatever throw statement you are having in this function, inner function, that also will be carried, okay, and given to this catch in this outer function. That is why the output will be a caught exception in the inner function, caught rethrown exception in the outer function. Though in the outer function you are not throwing anything, but in try you are calling something which is throwing something. Okay. In try block you are calling inner function which is throwing an exception. So its corresponding catch it will execute, and also this throw will be sent to outer function also. Why? See, we wrote a keyword throw semicolon. We wrote a keyword throw semicolon. This is same as your nesting out the exceptions. Okay. Why it is called rethrow? Means inner function there is an exception which is happening, that error message I am giving, that whatever is thrown here, that is also copied into this throw message, and that is given to this catch block here. Okay. This is your rethrowing an exception. Okay. So this is one very important point. Even though you are not directly throwing something in this outer function, this inner function you are throwing something. Additionally, you are writing second time throw keyword, rethrow. Once you are throwing, again you are throwing it. Once you throwed it for this catch function, second time you are throwing for this function call, or the catch block inside the parent function call. Okay. So from main the control is shifted to outer function. From outer function the control is shifted to inner function. Inside inner function I am having a try, I am throwing something and there is a catch. Then I am throwing again I am throwing. So this is satisfied here, a try with a throw and a catch. But again I am simply writing throw. This throw is given to the outer function, it has a catch. Whatever it throwed here, the same thing I will be throwing it here also to this outer function. So this will also do some message. then the control will go to the main block, right. So, this is your rethrowing an exception. Now, you see here, rethrowing an exception in C++ involves catching an exception within a try block, okay, within a try block, and instead of dealing with it locally, throwing it again to be caught by an outer catch block like this. You are having a throw, but you are not dealing with it. This is not mandatory. This is not mandatory. You write throw and you again write throw without any catch. This catch will hold it. This catch will hold it. Okay, right. By doing this, we preserve the type and details of the exception which occurred in the inner function. Okay, by this what is happening here? Whatever error happening in the inner function, that is captured and preserved even in the outer function, right. This approach becomes particularly valuable when managing exceptions at multiple levels or when additional actions need to be performed before resolving the exception. Okay. So, one function exception came, that has to be known to the outer function also. If some other function has called this, it also has to be known. That way you can nest it, or you can implement kind of hierarchy, right. So, this is about throwing an exception, right. Now, the important terms which we have been using in our exception parts, right. So, this example, if you see, throw runtime error. See, you want to throw a number, you can write 10, or you can write throw x, or you can throw a character also, throw single quote a, or you can write throw a character variable. You can throw like this. But if you want to throw a message, to the catch block, you have to write like this, using keyword throw runtime underscore error. You have to use the keyword runtime underscore error. In this, you write whatever message you want to write. User defined message. Okay, division by 0 not allowed. This error is because of divide by 0. Any message you can write it here. You can use the keyword runtime underscore error. Throw runtime underscore error, any generic message you want to write it there. Okay. Now, that when you are throwing a generic message, there should be a function to catch it. So, whenever you are using runtime error in the throw statement, then your catch should be something like this: catch exception ampersand e, meaning for this string is copied into this address e. This is an object. This e is an object. Whatever string message you wrote here, that is copied into this. E. Then what has been thrown from here? If you want to know that, you have to write e dot what, meaning what has been thrown from the try block. Whatever the user wrote, that you print it using e dot what. This is the object, that is ampersand is the address, and what. So, what is a function which gives the detailed description of the exception which is thrown by the try block. Whatever this try block is sending, to send, see this example, to send integers it is okay, or to catch every exception it's okay, but you want to throw here I am throwing integer, here I am throwing a character, right. But if you want to throw a detailed explanation like this, some message you want to give, then definitely you have to use runtime underscore error and write that message, and there should be a corresponding catch statement with exception ampersand e. There you are writing cout exception e dot what. When you write this, whatever has been transferred from the try block, that will be received here and printed. So, for this program, the output will be division by 0 not allowed, that is it. How did I get this? Exception, it will come something like this, exception, because there is exception here, space division by 0 not allowed. This is the output. Okay. So, same thing here also we have used in this program. If you see, in rethrow also I have used, see, try throw runtime underscore error an error occurred in inner function. And here I am writing constant runtime error ampersand e. If you know that it is a runtime error, you can write runtime error directly. If you do not know what it is, simply write exception. Simply write exception in the catch block, exception ampersand e, that is it. And here you write cout e dot what, it will tell you what has been thrown from there, right. So, this is about exception handling in C++. If you summarize what we have studied, it can be achieved using 3 block of statements: try, catch and throw. Okay. And we can write something like this: try block where you want to write the logic and with a throw. Then there should be a corresponding catch block which will catch that error and print the message. Okay, right. And we have seen some properties that you can, if you want to capture everything, you can use catch all, that is catch followed by 3 dot symbols, right. If you are throwing some integer, there should be an integer catch function. If you are throwing a character, there should be a character matching function, right. And if you are throwing a type but there is no corresponding catch, program will terminate abnormally. Okay. And you can even rethrow using throw keyword. Once you throw it, again you can use the throw keyword to throw it multiple times. And the important point, you can have multiple throw statements and multiple catch statements. The execution of constructor destructor, if you are creating an object in try block, then before you are throwing the control to the catch block, both this constructor and destructor will be executed. And the last one is rethrow. You can have rethrow, use the keyword throw to throw an exception which occurred in the inner function which was called in the outer function, right. So, this is about exception handling in C++.